Greetings, I greet to Madam Razima and to the members of the floor. My name is Adela Nicola Venus with a registration number of 07DKA22F1031.
I'm Suraya. My registration number is 07DKA22F1009. Today, we will presenting on the topic differentiation and the subtopic turning point.
So we were given an equation to solve using the differentiation method, and we're also gonna find the nature by using the second derivation. Okay, so we will directly jump into the equation that was given to us. So the first step is that we need to differentiate this equation. So as we know, when we want to differentiate an equation, we need to times the power in front here, and we will minus with 1 each of the power. So the answer will be, when we differentiate the equation, we will get 3x squared minus 12x and plus 9. So from this equation, we know that when the turning point is actually, the equation will be equals to 0. So when it actually equals to 0, we can use the calculator, the EQN method, by pressing this number, and we will get x1 will be equals to 3 and x2 will be equals to 1. So next step, when we already find the 2x, the value of x's, because as we can see here, there's actually a square here, so the value of x will be more than 1, which is 2. So when x is 3, thus we will substitute the 3 inside the first equation. So when we substitute, we will get y is equal to 3 to the power of 3 minus 6 in the bracket of 3 to the power of 2 plus 9 in bracket 3 and plus 5. So eventually we will get y is equals to 5. Next, when we substitute x equals to 1 inside this equation, so we will get y equals to 9. So therefore, we know that the stationary points are 3, 5 and 1, 9. Because the value of x is 2, therefore the value of y will be the same. So when we already find the stationary point, now we need to determine whether the points are minimum or a maximum point. So in order to do that, we need, actually, when we need to find the minimum and maximum, it is when we are determining the nature of the points. So here we will be using the second derivative method, which is d square y over dx squared, which is equals to this equation. We will differentiate it on the second time, which is we will get 6x minus 12. So when x is 3, we will be using the same points, which is we get from here and here, just x equals to 1 and x equals to 3. We will substitute this point, inside this equation. So when we substitute x, we will get the value is 6. So we know that 6 is more than 0. So when 6 is more than 0, we know that the point is actually a minimum point. However, when we substitute x equals to 1, we will get negative 6, which means it is less than 0. So which means it is a maximum point.
Next, we move to the last step, that is we need to sketch a graph. First, we need to draw a table. It's 6 rows and 2 columns. Next, we put the stationary point in the table. We leave the before and after the table empty to calculate another coordinates to support our graph. Next, we just put some random number to find the y. I choose 0, 2, 4. And we substitute the number that we pick in the original equation to find y. Then y equal to 5. Then we put the 5 into the table. We repeat the step, but by using the different number of x. When x equal to 2, thus y equal to 7. When x equal to 4, thus y equal to 9. Finally, we go to the final part that we need to sketch the graph using the coordinate that we already computed. The first one is 0, 5. 0, 5. Next, 1, 9. 2, 7. 3, 5. 4, 9. Next, we connect all the points. So, this is the maximum point of this graph. This is the minimum point of the graph.
That is all from us.
Thank you.
Okay.